class. Hope you're doing well. So in this session, we want to solve a problem using the methods of Trapezoidal and Simpson's 1/3 rule. So we just do an example in this session. So we have the integral from 0 to 1 of e raised to power x divided by 1 plus x. And we want to integrate this with respect to x using the trapezoidal rule, and 2 using the Simpson's 1/3 rule. So we first recognize that we have a function which is given by e raised to power x divided by 1 plus x. So whether we want to use the trapezoidal or Simpson's rule, the first step would be to tabulate this function in the interval between 0 to 1 using the steps of 0.1. So in this case, we just have a table of values x and the corresponding values of the function. So x is 0. Then we use the steps of 0.1. So the next value will be 0.1, then 0.2, 0.3, and so on. So when x is 0, for example, we have e raised to power 0 divided by 1 plus 0, which is 1 divided by 1, which is 1. Then when x is 0.1, then we can calculate e raised to power 0.1 divided by 1 plus 0.1, which is a value. We can get this value, 0.1, like that. And we can get this value if you use a calculator. You can get a value of 1.0047. Similarly, when x is 0.2, we substitute and we get 1.0178, and so on. When x is 0.3, the value of the function is 1.0354. So we tabulate this function. When x is 0.4, we have, let me write the values down here so that we can have more space. So I'll have the values of x and the corresponding value of the function. So when x is 0, we have seen we have 1. When we have 0.1, we have 1.0047. 0.2, the corresponding value of the function is 1.0178. The value of x is 0.3. The corresponding value of the function is 1.0354. We are using 4 decimal places. 0.4, we get 1.0656. 0.5, we have 1.0991, and so on. When x is 0.6, the value of the function is 1.1388. 0.7, we have 1.1846, and 0.8, we get 1.2364. 0.9, the corresponding value of the function is 1.2945, and the 1.0, then the value of the function is 1.3591. So now we are going to go now to use the trapezoidal rule. The trapezoidal rule is as given here. This is the trapezoidal rule. So f naught is the value of the function when x is x naught. In this case, x naught here is 0. So we're going to have this as x naught, x1, x2, and so on, so that the corresponding value of the function here will be f naught, f1, f2, f3, f4, and so on, f5, f6, f7, f8, f9, up to f10, the last entry there. So in this case, we see that the integral from a to b, in our case, is from 0 to 1. In our case, we have the integral from 0 to 1 of the function e raised to power x divided by 1 plus x. Now, we are going to write it as h divided by 2. Then we have f naught plus 2 times the sum of all the mid-ordinates, that is f1 plus f2 plus f3, and so on, f4 plus f5 plus f6 plus f7 plus f8 plus f9, we close the brackets, then plus the last ordinate f10, then we close the bracket. So in this case, you're going to add the sum. We are going to get the sum of the values of the function from f1, f2, f3, f4, up to f9. We add all those values and then multiply by 2. Then the last entry is not multiplied by 2. The first entry occurs once. Then we multiply by h divided by 2. Now our h is 0.1, the step length. So we have the integral from 0 to 1 of our function, which is e raised to power x divided by 1 plus x, becoming 0.1 divided by 2. Then f1 is 1. Then we have plus 2 times. Now we add all the other values except the last one. So we start with f1, which is 1.0047. 1.0047. Then plus the next one, which is f2, which is 1.078, 1.0178, sorry, then 1.0354, then plus 1.0656, and then we add 1.0991, 1.1388, plus 1.1846, then plus 1.1236, sorry, this is 1.2364, then plus 1.2945, which is f9. So we cross the brackets. Then we add f10, which is 1.3591. Then we cross that bracket. So if we work out this, then we express our answer correct to 4 decimal places, then the result is 1.1260. So you notice that in this one, using this method to evaluate the integral, we just need to tabulate the function given here, this function, over there interval of integration, in our case it was 0 to 1, using a given step size h. In this case, the step length is given as 0.1. So we use the steps of 0.1. And then we add the first and the last ordinates are not multiplied by 2, but all the other ordinates are added together, and the result multiplied by 2 before adding to the first and the last ordinate, and then multiplying the result by h divided by 2. Now, Simpson's rule, the Simpson's 1/3 rule in this case, is another technique that can be used to evaluate this integral. For Simpson's rule, we require that the number of ordinates be odd, so the number of intervals is even. In our case, we have 11 ordinates and 10 intervals, so the condition is satisfied. So we have, again, I'll not write the values here, but let me just write something. We tabulate the function from x0, x1, x2, x3, and so on up to x2n, and the corresponding value of the function f0, f1, f2, f3, all the way up to f2n. So in this particular example, where we had x0 was 0.1, and the corresponding value of the function f0 is 1, then we have, sorry, this was 0.0, then 0.1, we had 1.0047, 0.2, and we had the values. Maybe I can just write them again here, and just reproduce them again here. 1.0178, 0.3, we had the value as 1.0354, 0.4, the value was 1.60656, 0.5, the value is 1.0991. When x is 0.6, we have 1.1385. When x is 0.7, the value of the function is 1.1846, and x is 0.8, the value is 1.2364, 0.9, the value, we have 1.2945, and 1.0, the value of the function is 1.3591. So when using the Simpson's rule, the coefficients of this method are in such a way that the first coefficient here is 1, then the next one is 4, then 2, then 4, then 2. They alternate between 4 and 2. So we have 4, 2, 4, 2, 4. Then the last one is 1. So the coefficient is 1 for the first one is 1, followed by 4. Then the last one is also 1. So that when we are writing the method, the value that we have here, for example, 1.0047 will be multiplied by 4, the corresponding coefficient in the method. the value like 1.1078 will be multiplied by 2. The next one by 4. The next one by 2. The next one by 4, and so on. So that if we have so like that. So in this case, when we call this the first one here F0, then this is F1, F2, F3, F4, F5, F6, F7, F8, F9, and F10. You'll notice that all those ordinates with odd subscripts are multiplied by 4, and all those ordinates with even subscripts are multiplied by 2, except the first and the last ordinate. So in this case, we can write the formula, the integral from 0 to 1, f of x dx, in this case as h divided by 3. Then we have f1 plus 4 times, this is f0, sorry. So f1 plus f3 plus f5 plus f6, f7 plus f9. Those are the odd ordinates. Then the even ones, except the first and the last, are multiplied by 2. So we have 2 times f2 plus f4 plus f6 plus f8. The last ordinate is multiplied by 1. So we have f10. We close the bracket. So in this case, we shall write h divided by 3. Then we substitute the value of f0 as 1. The values that we have here is 1. F1 is 1.0047. F3 is this, F5, F7, and so on. And when we work out all this, we should get a value of 1.1254. So the method, the Simpson's rule, is usually more accurate than the trapezoidal rule. So we can expect that this value is more accurate than the previous value. But depending on the step size, if you make the step size smaller and smaller, then even the trapezoidal can become very, very accurate. So basically, these are the two methods, the Simpson's 1/3 rule and the trapezoidal rule. So the basic thing here is that when you are given an integral, the first step is to tabulate the function occurring there, the integral. You tabulate that over the interval of integration using the given step size. Sometimes you are not given the step size, you are told maybe using 10 steps. If you are told using 10 steps, it means that you divide the interval of integration, in this case, from A to B by 10 to get the step size. In this case, it would be 1 minus 0 divided by 10, which is 0.1 in our case. If you are told 20 steps, then you can divide again by 20 and so on. So thank you for watching. This is basically the two methods I wanted us to discuss here. Basically do an example. I hope this will be helpful. Thank you.